We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Okay. Good afternoon to all. Today we have discussed regarding the topic which is known as amplifier. First of all, what is the meaning of amplifier? Amplifier means to increase the amplitude of the input signal, to increase the amplitude of the input signal without changing the frequency, to increase the amplitude of the signal without changing the frequency. So, if it is input signal, it is considered as an input, then what is the output to increase the amplitude? See this is input and this is output. It is known as concept of amplifier. So, we have applied the AC signal to the input. And if you can apply the AC signal to the input, then we have put here capacitor. What is the role of capacitor? Then I will explain here what is the role of capacitor. Here it is known as transistor. R1, R2 it is the resistor. RC is the resistor. RE is also known as resistor. Now, it is known as coupling bypass capacitor. It is known as input capacitor. It is known as output capacitor. Why this capacitor is required? That I will explain here. Why this capacitor is required? What is the basic function of capacitor? It is used to block the DC component, or it is remove the DC component. If this capacitor is charged, then it blocks the DC component from the input and pass only the AC component. And if you can see here, it is also known as output capacitor. Why we have put here capacitor? Because capacitor is used to block the DC component. And if here we cannot put the capacitor and directly apply to the load resistor. Load resistor means what? Any type of device, like loudspeaker, like fan, like tube light. But in general, in amplification purpose, here it can be connected with loudspeaker. And if loudspeaker can accept the DC signal, or in loudspeaker, if we can apply the DC signal, then we cannot get the 100% information. That's why we have put here capacitor to block the DC component. Means input of capacitor is act as a AC plus DC both component, but output of capacitor only contain the AC component. Remove the DC. DC signal cannot be passed in the capacitor. This is the basic function. Now see this. Input signal, it can be act as a AC signal. AC signal that can be passed from capacitor easily. Why we have put this capacitor? I will explain this later on. Then at this point, AC component only present. But at this point, consider this is the F point. At F point, both components are present. It is known as AC plus DC. Both components are included in this particular circuit. Now, see what is the interesting scenario can be developed. At the base terminal, two current can be flow, AC current plus DC current. As base terminal, two current is flow, AC base current plus DC current. Remember this point. This is the most important point. AC current plus DC current. Now, due to base current, collector current is flow. And this collector current is also known as AC collector current plus DC collector current. Due to formula of IC equal to beta time IB. IC equal to beta time IB, this current is also flow. Remember this point? In previous lecture we have discussed the theory which is known as voltage divider biasing. That's why it is known as common emitter amplifier, voltage divider biasing. They are the different name. Now, see this step number 1, base voltage is increased. Base voltage means this. Base voltage is increased, then collector current IB equal to IB plus AC collector current is also increased. So collector current is increased according to formula IC equal to beta time IB. This is the most important step. Remember that point. IC equal to beta time IB. So collector current increase. So ICRC is increased. But here we can see that VCC is constant. So VCC is constant. ICRC is increased. Assume that this is 20 volt. Here it is 12 volt. So here it can be voltage must be equal to 8. But if here voltage is increased from 12 to 16, at that time VC is decreased from 8 to 4. Again repeat, VCC equal to ICRC plus VCE. Here voltage is, here it is 16, so here it is 4. A constant voltage of VCC, VCC equal to 20. Now if voltage is decreased, ICRC is decreased from 16 to 14, at that time VCE is increased. But if ICRC is increased from 16 to 18, at that time VCE must be decreased. So phase shift between input and output, see this very carefully. Base voltage is increased, collector to emitter voltage is decreased. And again repeat, base voltage is increased, collector to emitter voltage is decreased. So if input is increased, then output is decreased. It is known as common emitter amplifier. That's why in output voltage we can get the 180 degree phase shift with respect to input signal. In output signal we can get the 180 degree phase shift compared to input signal. This is the advantage of common emitter amplifier that I have described here. Now, what is the role of capacitor? This is the most important role of capacitor. It is, again repeat, it is known as input capacitor, it is known as output capacitor, it is known as coupling capacitor. Coupling capacitor, or we can say bypass capacitor. What is the role of bypass capacitor? See this is input capacitor. It blocks the DC component, pass the AC component. 3 capacitor I have put in the circuit. Working of 3 capacitor is same. But here see this. Here interesting scenario can be developed. I will explain this point here very carefully. See this, I will sketch like that. At this particular point, AC plus DC both components are present. Remember that point. AC plus DC both components are present at this particular point. Remember the point. I will also locate the different mark. This is for AC signal. This is for DC signal. Remember that point. Now, at particular point, AC current plus DC current both are flow. It is known as emitter current. Why? Because in terminal it is known as emitter, base and collector. Now, what is the role of this capacitor? Both current that can be passed here, AC plus DC. Remember that point. Both current can be passed here. It is known as AC plus DC. But if we cannot put here capacitor, then AC plus DC current that can be also passed from resistor. But if we cannot put here capacitor, assume that we cannot put here capacitor, then AC plus DC or plus, minus, minus, plus. See this polarity, plus, minus, minus, plus. And again repeat, plus, minus, minus, plus. It is known as DC current plus AC current. Due to DC current plus AC current, it blocks the input signal. Remember that point. Positive, negative, negative, positive means feedback voltage can be subtracted with input. This is concept like emitter bias. Plus, minus, minus, plus. Concept like emitter bias, input voltage is decreased. But if input voltage is decreased, then it is okay for biasing. But we want to design amplifier in terms of amplification application. Means what? We want to design the amplifier in terms of amplification. At that time, if input voltage is decreased, remember that point, for the purpose of amplification, if input voltage is decreased, then collector current is also decreased. Collector current is decreased, then we cannot get the sufficient output. So for the purpose of sufficient output, or we can say for the purpose of amplification, it is required to maintain input voltage at sufficient level. Remember that point, we want to maintain the input voltage at sufficient level. Or simply saying simple English, we want to maintain or we want to control the input voltage. If input voltage is not controlled, then output voltage is not controlled. That's why plus, minus, minus, plus, it is known as subtractive polarity. If we cannot put the capacitor, see this, if I will not put the capacitor, then AC component and DC component both can be passed in the circuit. But if we can put here capacitor, then only DC component can be passed from this circuit and AC component can be passed from capacitor. AC signal can pass from capacitor because capacitor blocks the DC component and DC component can be passed from here. Again repeat, DC component can be passed from here, AC component can be traveled through like that. It is known as AC current. And for AC current, capacitor can be act as a short circuit. So it can be considered as a short circuit. But it is applicable only for AC, remember that point, not DC. It is applicable only for AC, not DC, remember that point. This is the most interesting point. Again, at this point AC plus DC. If we cannot put the capacitor, then simply say in one language, voltage gain is reduced. If we cannot put this capacitor, then voltage gain is reduced. If voltage gain is reduced, then it is not the convenient amplifier. Or this is not, we can say, reliable amplifier. At that time, voltage gain must be increased. If voltage is increased, then current is increased. So voltage multiplied by current, V multiplied by I equal to P. It is increased if and only if voltage is increased. Try to understand again. If voltage is increased, then current is increased. Current is increased, then power is increased. That's why we can put here capacitor. That's why we can put here capacitor to improve the voltage gain. To improve the voltage gain, that's why we can put here capacitor. Now, please concentrate here. If we can put capacitor, then DC component can pass from here. If DC component can pass from here, then also here AC plus DC both components are present. No problem. If DC and AC component are present, then this capacitor is used to block the DC, and output of this capacitor is only AC component. In starting of the theory, I have already explained what is the role of capacitor. I will explain here. Again repeat, this AC signal can pass from this capacitor, but here plus minus it is known as DC current. And due to this DC current, DC voltage is dropped. And due to this DC voltage drop, plus, minus, plus, it can be added with each other. Remember that point. How AC component can be added with DC, that I will explain here in terms of waveform. AC plus DC add, and due to this capacitor, DC component is blocked, and output of this is known as pure AC. This pure AC signal that can be applied here. Now, due to VCC, base current is introduced here. Remember that point. Due to VCC, base current can be introduced here, which is known as DC current. And due to base current, collector current is flow, IC plus small ic. Remember that point, two different values. Small IB indicate AC current, capital IB indicate DC current. So this is the explanation of common emitter amplifier. You have to write this step in the theory. Remember that point. Don't write anything. Only write this fourth step and waveform. Don't do anything. This is the final answer of the common emitter amplifier. Most important question regarding GTU examination. Most important question regarding GTU examination. It is just mention the step number 1, step number 2, step number 3, step number 4. Draw this diagram and write the difference between AC current and DC current. Again, it is known as voltage divider biasing amplifier. Clear? Waveform I will sketch. Waveform I will sketch whenever I have erased this particular data. So please remember this point. Base voltage is increased, then AC current is increased. So collector current is increased. Collector current is increased due to the fact IC equal to beta time IB. Remember that point here, amplitude is increased. Amplitude is increased here, I will explain the waveform. And due to increase in ICRC, VC is decreased. If VC is decreased, then input and output phase shift is 180 degree. So it is the topic of common emitter amplifier. Most important topic regarding the external examination. Question asked like that, explain common emitter amplifier with necessary waveform and working principle of common emitter amplifier. At that type of question that can be asked. Also question asked like that, explain the concept of VDB amplifier, voltage divider bias amplifier. So this is known as bypass capacitor, this is known as input capacitor, this is known as output capacitor. In output signal also, if we can apply the DC signal to loudspeaker, then loudspeaker cannot give the exact information. At that time, output capacitor is required. At the sum of time in real application, in loudspeaker, some type of hissing noise or unwanted noise, you will able to listen in your ear. It indicates the DC voltage that can be present at the loudspeaker. What is the characteristics of DC signal? It is known as 0 Hz frequency. We cannot able to listen this 0 Hz frequency. That's why it can be considered as a noise if we can apply the DC signal to the loudspeaker. RL means load resistance, means simply say loudspeaker. Is loudspeaker accept the DC signal, then we cannot able to listen the loudspeaker sound. At that time AC signal must be required, so we can put this capacitor. I think you will able to understand what is the role of capacitor. It is input capacitor, output capacitor, coupling capacitor or bypass capacitor. Capacitor is only one, but three different names is given: input, coupling and bypass. This is the final theory of common emitter amplifier. I will explain the waveform very clearly, so you will able to understand what is the meaning of common emitter amplifier. Input signal and output signal 180 degree phase shift with respect to each other. So today we have discussed the waveform regarding common emitter amplifier. Remember that point? In examination you have to sketch the waveform in this particular manner only. Remember that point? This is the most important waveform according to external examination. Now see this, first of all it is known as input signal. See this input signal. Input signal contains two cycles, positive cycle, negative cycle. In my entire waveform, negative cycle it can be represented in terms of line. Remember that point, negative cycle it can be represented in terms of line, and positive cycle in terms of represent blank space. So positive, negative, negative. This is the negative input cycle. See this. Now, it is the pure constant DC voltage that can be applied through the VCC. VCC plus VCC. Due to plus VCC, it is the constant waveform. So it is known as constant. Now these two components, two waveforms that can be added with each other. two waveforms that can be added with each other. So we can get DC signal shift with respect to axis. With respect to time axis, DC signal is shift. With respect to time axis, DC signal is shift. So here it is known as AC plus DC. So AC plus DC, positive cycle, negative cycle, positive cycle, negative cycle. It is known as base current that can be applied at the base terminal here. See this, it is known as base terminal, or we can say F point. So here I have mentioned it is known as F point. Now, due to this base current, collector current is flow. It is known as IC. IC equal to beta multiplied by IB. So overall amplification we can get only the factor of beta. Overall amplification we can get with the help of beta only. So it is known as IC equal to beta time IB. Now always remember that base current is always low value, collector current is always high value. So IC, it is known as IC, and voltage drop across RC, it is known as ICRC. So remember that point, amplitude is also increased. Remember that point, base current amplitude is always low, collector current is amplitude is always high, ICRC is always high, and if ICRC is high, then VC is low. According to the equation, VCC equal to ICRC plus VCE. VCC equal to ICRC plus VCE. ICRC is increased, then VCE is decreased. See this very carefully. ICRC increase, VCE is decrease. ICRC decrease, VCE increase. ICRC increase, VCE decrease. ICRC decrease, VCE increase. This is the increasing mode of ICRC, so this is the decreasing mode of ICRC. Why it is decreasing? VCC is constant. Due to VCC constant, if ICRC increase, VCE is decrease. ICRC decrease, VCE increase. ICRC increase, VCE decrease. ICRC decrease, VCE increase. So it is the entire waveform. In this respective of entire waveform, it is the most important. Remember that point. Here again, AC plus DC both component are present. With respect to time axis, signal divided into upper part as well as lower part, it is known as AC signal. Remember that point. With respect to time axis, signal is divided into upper part as well as lower part, it is known as AC signal. But if signal is divided into only upper part, see this, only upper part is present. At that time it is known as pure DC, it is known as pulsating DC signal. It is known as pulsating DC signal. Up till this point we can get pulsating DC. Remember that point. Up till this point means this is known as B point. So it is the waveform of B point. And here waveform of output, it is known as D point output. Due to capacitor, DC component is removed. Here AC plus DC both components are present. Here AC only component are present. So here we can say that input signal and output signal 180 degree phase shift with respect to each other. Input signal and output signal 180 degree phase shift with respect to each other. It is known as diagram of common emitter amplifier. You can sketch this diagram first of all. Then I will describe the all other theory that you have mentioned. Definitely step 1, step 2, step 3, step 4, and then you have to sketch this waveform. This is the most important theory regarding the external examination or in terms of understanding. What is the use of capacitor? Input capacitor, coupling capacitor, bypass capacitor. I will explain here what is the role of this. I will erase this figure. Notation of input capacitor is known as Cin. Cin means it is known as input capacitor. Input capacitor block the DC component. Block DC component only pass AC signal. Only pass AC signal. It is the role of input capacitor in common emitter amplifier. What is the role of coupling capacitor? Coupling capacitor symbol is Cc. coupling capacitor it is used to improve overall voltage gain of system, overall voltage gain of amplifier. It improves the overall voltage gain of amplifier. It blocks the DC component. It blocks DC component. It is the coupling capacitor, or we can say bypass capacitor. It is known as bypass capacitor. Why it is known as bypass capacitor? It passed the only AC component and put across the parallel across the RE. Put in the parallel across the RE. So it is known as coupling capacitor. It is known as, or we can say bypass capacitor, input capacitor and output capacitor. Output capacitor means output capacitor, it allows only AC component and AC component, AC given to the load resistor. It is the role of output capacitor. It is known as input capacitor. It is known as bypass capacitor. Bypass capacitor put across the RE resistor. Write down this statement very carefully. Bypass capacitor put across the RE resistor. Put across RE resistor. This is the most important statement. This is the most important statement, and this is the role of entire capacitor. Input capacitor, bypass capacitor, output capacitor. Role of RE, RC and R1, R2 already mentioned in the previous theory. It is used to control the base current. RE is used to introduce the negative feedback. Due to negative feedback, gain of the amplifier is reduced. That's why we can put the parallel capacitor, which allows the AC component pass through it but block the DC component, so we can get sufficient level of amplification. And why it is known as amplifier? See this in last point. Why it is known as amplifier? Input voltage in terms of millivolt, or we can say microvolt input voltage. Input voltage is microvolt, and see this output waveform. We can get the graph like that. It is known as output, so it is known as amplification. So it is known as amplification process. It is known as amplification process. In amplification process, you have to write the step 1, step 2, step 3, step 4, and you have to write the role of capacitor. Draw the input-output waveform, whatever mentioned in the particular video. So it is the entire explanation of common emitter amplifier. With amplification process. Amplification process means what? Step 1, apply the input. So base current is flow. Step 2, due to base current, collector current is flow. Step 3, collector current is flow according to IC equal to beta time IB. So ICRC is increased. If ICRC is increased, then VC is decreased. Step 4, due to VC is decreased and due to presence of capacitor, we can get the AC plus DC component. And step 5, if you can apply the capacitor, then we can get the output in terms of pure AC signal. It is known as pure AC with respect to time. Remember that point. With respect to time, upper side and lower side both are present, so it is known as AC signal, or it is the process of amplification. It is the process of amplification. So you have to write the entire waveform, input output waveform explanation. You have to write clearly whenever asked the question common emitter amplifier. And again, the most important point, whenever asked in the examination amplifier, at that time you have to must be applied the AC input. Remember that point. Don't forget in the examination, amplifier means what? To apply the AC input to the signal. Or simply saying Gujarati language, amplifier હોય એમાં AC input જ આવશે, DC નહીં આવે. DC represent in terms of supply voltage. Be carefully representation. While you write the paper, at that time purely concentrate on your mind. Based on that you have to give the answer. Thank you very much. Draw the diagram clearly with apply AC input. Remember that point. AC input, it is the most important for the amplification. Input voltage is low, output voltage is high. It is the purpose of amplification.